So in this video we are going to talk about the definite integral, still the same thing that we've been talking about in the most recent videos, except this time we're going to describe the definite integral in words rather than formulas and symbols and stuff. So you saw in the previous video that we saw what units a definite integral could have, alright? And we also know that one interpretation of the definite integral is as a signed area. Remember, it's signed, right? It has a sign because if the graph goes underneath the x-axis, it's going to be negative, and if it's above the x-axis, then the integral is going to make it positive, in which case you just get the ordinary area, right? So we know it's the signed area between the graph and the x-axis. What else could it be? And so let's suppose, just for the time being, that f is a function which is a rate of change, all right? F is going to represent the rate of change of something per unit time. And t, of course, will represent time. So the variable that we're integrating with respect to is time. So again, f is a rate of change, and t is time. All right? So now, how could we interpret the derivative given those two facts? So let's look at it again. So remember, the integral just means to add stuff up. But what kind of stuff are we adding up? Well, if we go back to our geometric interpretation of the integral, we know that f of t represents the height of something, and dt represents the length of something. When you multiply these two things together, what do you get? You get the area of a rectangle, right? That's what we've been doing. But this rectangle is a little special. It's not the one from a Riemann sum. It's one from the integral is actually, in a way, a continuous sum. So we're adding up infinitely many things because dt is infinitely small. Anyway, that's what we're adding up. We're adding up areas of rectangles. But now let's look at it from a different point of view. We know that f is a rate of change, so what are the units of f? Well, in the previous video we saw that f is going to have units of whatever the units of the change are divided by time, and dt, since t represents time, is just the difference of two times, so that'll also have the units of time. When you multiply these two things together, time cancels out, and you just get change, right? Now, when you add up all the changes over the region A to B, what do you get? You get the total change of the function f over the interval AB. So actually, let me just cross that out. This is just the total change of the top, right? The units of the numerator of f over AB. So that's what's going on there. Another interpretation now that you have of the integral of the definite integral is that it represents the total change of a quantity, as long as you're integrating a rate of change. All right? So let's go over some examples. This will be very similar to the previous video, except now we're going to actually interpret the result of the integral as opposed to just getting its units. So let's say p of t is the rate at which you eat pizza at the time t. T is the number of minutes since you've started eating the pizza. So if t is equal to 0, that means that's exactly when you start eating the pizza. And now let's say you just continuously eat pizza for 30 minutes. All right? And you want to find out what the integral from 0 to 30 of this function p of t is. Notice I've carefully made it a rate of change, right? It's the rate at which you eat. The units of it are going to be pizzas per minute, right? Now, we know the units are going to be pizza per minute. We multiply by dt, and we're going to get units of pizza. But we know that since we're integrating rate of change, what we're really going to get is pizza, or total amount of pizza eaten during the interval. Let's say during the time interval of 0 to 30. In other words, the first 30 minutes. Okay, so that's what's going on there. You integrate the rate of change at which you eat pizza, and if you integrate over, say, 0 to 30, all you're getting is how much pizza you ate over the first 30 minutes. Of course, assuming that you haven't eaten pizza at time 0. That's when you start, right? Okay. Let's go to another example. Let's say the rate at which you complete web work, and t represents the number of hours that have transpired since you started doing homework. So again, at time equals 0, at time equals 1, you haven't started anything, right? But now we're going to integrate from 1 to 3. So what's the integral? What's one way to describe what the integral of h of t is over the interval 1 to 3, the time interval 1 to 3. So t is in hours. You want to integrate from 1 to 3 hours. Let's go ahead and quickly find the units. So h of t has units of web work, problems completed, per hour, right? And dt has units of hours. So hours cancels out, and you're getting the number of web work problems you've completed. But now look, we're integrating from 1 to 3. So what are we going to get? We know that the integral represents the total change, but the total change of what? It's the total change of web work problems completed from the time t equals 3 hours compared to t equals 1 hour. So it's just how much homework you completed between 1 and 3 hours. That's all it is. So it's the total change in completed homework problems, or let's just, okay, web work problems. Over, or let's just say from 1 to 3 hours. This can be equivalently stated as the amount of homework or web work problems you complete or completed from 1 to 3 hours. And that's all. All right. So remember, so again, just to summarize everything we've done in this video, we've looked at the definite integral, and now we have two interpretations of it. Here's one, and here's another. The one that we've first started out with was the geometric interpretation of the integral as a sort of idea of an area. What kind of an area? A signed area. Why? Because you're going to find the area under the curve and below the curve, trapped between the curve and the x-axis, I mean. But if the curve lies below the x-axis, then you're going to put a minus sign next to that area. So it's a signed area. And now we know that if f of x, or f of t in this case, if f of t represents a rate of change, then when you integrate a rate of change, what you get is the total change over that interval. And there you have it, two interpretations of the integral. We're going to have one more coming up in the next in a future section, and so we'll have a total of 3. So stay tuned.